All right, so welcome folks. This is our programming interviews easy session. So what we'll do is we'll spend the next 1 hour or so walking through some basic interview questions. We will cover some aspects of interviewing, which sometimes makes it a little interesting. Some of these sessions are, while under the guise of easy, we may end up covering a tad bit more complicated sets of questions as well. So let's jump right in. So we've got about 9 or 10 people on the conference at this point of time. I think most of you are actually on the audio bridge. I see one who's on the phone. So if you're on the phone, you may want to use the app to look at it, or you may want to just go to the Etherpad link, which is there. That should be able to get you just query the information. All right. So the first question is actually a pretty straightforward question. I would like you to write a program that actually accepts a word in English and then returns the Morse code for it. So a simple example would be SOS is essentially the same as S is 3 dots, O is 3 dashes, and again S is 3 dots. So an SOS is actually provided as 3 dots, 3 dashes, and 3 dots. The Morse code, each letter is separated by a space, so that way there is no ambiguity, there is no confusion. Anyone wants to volunteer as to how this would be accomplished? You'll have to unmute yourself to speak. Any takers? Why hash map? Any takers? I know one recommendation was like, let's do a hash map with print. Any other suggestions? Any other takers? It should be easy. It shouldn't take more than a couple of minutes. If you are following along and you have it, you should be able to type in the chat, in the Etherpad as well, and you should be able to just type the code as well. Abhi, you're not able to unmute yourself. Let me give me 1 minute. I think. Okay, can you please try now? I think it was in the wrong mode.
Oh, hey, yeah. Can you hear me?
Yes, I can hear you now. Thank you.
Yeah, I was thinking of like an hash map too, because it has like O of 1 lookup, and so that would be the quickest way to get the corresponding code.
Okay. Somebody recommended an array. Why would you use a hash map versus an array?
Go ahead.
Sorry, hash map insertion time amortized, I'm not sure, but array insertion time would be order of 1 as well while building this lookup array of these strings.
Okay. So fine, and pick a language of your choice and write the code. Let's take like 5 minutes and write this code for this one. This should be super straightforward. Do you have you have access to the Etherpad link, right? All right, awesome. Who's typing? Okay, all right, NG, go ahead. Don't have to define the array, just like assume the array is there. what would int of C give you?
Yeah, I was not actually sure how to convert the character to integer in Python, but I figured if it is a character, int of C should give me the integer, or if it gives me the ASCII code, then this won't work.
Most cases, like you'd want to get the ASCII code, and then you just you subtract A from it, and that just gives you, like, assuming it can give you the character value.
Yeah, but we would again need to do -1 as well.
Why do you do -1?
They should work just fine.
Right? Okay. And
then that's it. That should work.
Okay. Now, what if I tell you that this program fails 100% of the test cases? Then what do you think could be possibly wrong?
Am I parsing the string wrong? Or?
No, it's all fine. It is actually saying that expected is this, actual is this, and it fails.
Oh, with the space.
So what's the problem?
With the space in the end?
Mm-hmm.
Okay.
So how do you fix that?
Then I'm not for
this might work. Actually, you're essentially doing a trim. So this is a reasonable choice, and it works. A couple of the other ways to do that is, and this is something that we need to keep in mind. At multiple points of time, you will be asked to convert like a list of entities into some sort of like delimited values, like, comma separated values or something like that. If you look at your array printing question, right, you'll have like, you want to print something like this, right? So at this point of time, you want to print something that is before the string, after the string, and between all the elements, you want to actually add like a comma or a tab or a space or something that's a delimiter for each of the entities. Now, in order for you to accomplish this, one thing to do is that one of the most common ways of doing it is what you have done in 57, is where you keep adding it after the value, and then at the end of the whole process, you just go and take away the last value. It is generally not recommended doing that, because you have essentially what you've done is you've created a copy of a string, and then now you're concatenating, you're adding more, and then you're like taking things away, and that's not as useful or as helpful. So one other way of doing it essentially would be to use like a if condition in this place, where you're saying that if C, not C, but essentially if you're saying that if ret length, right? If ret is empty to begin with, then you just add it as is. So you can do that, but then you're just saying if length of ret is equal to 0, then you can just do that, right? It's greater than 0, you can do that, something like that. So you are breaking the code in this way, but in this case, you don't have to do the -1 anymore, right? So this is one of the ways of thinking about how you do this. Okay. Any questions on this? Okay. Now let's do the reverse. Now the reverse is essentially I give you Morse code, so which means I give you this as the input, 3 dots, 3 dashes, space, 3 dashes, and this, and I want you to give me the output as SOS. So this is Morse code and this is Morse decode, right? Any thoughts on how you decode? Any takers? Come on, folks, you should be able to unmute yourself and you can speak.
So I know in JavaScript it should be the exact same code as I would do for encoding to Morse code, because it would just be, I would just have a map of the reverse map of what you have there and do the lookup, and then it would be the exact same code. Just the map I have would change.
Correct. But only two differences, right? One is that the map is reversed.
Yeah, and then when I jump.
Yeah, split by space. You're not splitting for C in STR.
Sure. Yeah, I wouldn't. Yeah. I would just join without space at the end.
Got it. Okay, fantastic. Now let's make it a little bit more interesting. Now, what if I don't have spaces? Now, what do you do? How will you figure out? Because this could very well be, I think E is single dot. It could be EI, O, EI, right? It could be this as well. Or it could be SOS, or it could be EEE, O, EEE. It could be any of this.
So I guess it depends on what is the expected output at this point. Should it be a combination of all possible, or should it still be SOS?
I just want you to print the number of possible combinations that you can make from the string.
Okay.
So the output for this, I'm assuming, is, I don't know, it's quite a lot, because I think the N is actually a dash dot, right? And T is a single dot. So I'm assuming that EEE, TTT, EEE is also a valid combination. It's EEE, TT, NEE is a valid combination, and so many of them. So I just tell me how many valid combinations are there.
So we take each. So we go character by character, and we take apart each character and see if that one character can make a valid character, can be decoded into a valid, English alphabet. And
but every character can be read. It's either a dash or a dot. Dot is a E, or I don't think there's a dash. Okay. There's a dash. Dash is a T. Right? So you can always have everything is valid. Always. So what do you mean by it can be encoded or not? You're on the right track. Go on.
so I think we are talking about dividing this pattern in all possible combinations, all possible valid combinations. So yeah, so when we take the first character out, we are again looking at the same problem for the rest of the string. Like when we take out the first dot out, then we have E, and we would again try to compute all the possible computations for the rest of the string. And so this will be one subproblem, but the second level would be when we take two characters, like, and again same with the three characters.
How do you Ajay's point was like, is it backtracking with characters? Not entirely sure. So can someone like tell me what is the maximum possible Like what's the total combination? So how many do you think you'll have? Is it 2 power n? Is it like n power n? Like
This
think
is
about it.
definitely NP hard.
So to tell me, so essentially I have a Morse code decoder, in which case the input is essentially a string S that's been given to you. Return the that's it. That's all I'm asking for. Okay. So what is your how do you go about doing this?
What about having like a pointer? So you start with I mean, I'm just thinking out loud. I don't know if this works, but so let's say your P1 is pointing at the like your string 0, right? And then you keep taking one at a time out. So for you take the dot out, you get 1, and then you take 2 dots out. You see if you get a character with it so you keep going till you hit a combination where you don't have a character, and then start from like the next character as scratch and keep doing that. Like so for example, like if you take the first 4, right, 3 dots and a dash, and that's not a character, so then you start from dashes your new character.
But how do you know how are you stopping that? Like 3 dots and a dash is not a character, but possibly you may have like 3 dots, a dash, and actually 3 dash and a dot and a dash is V, but let's assume it's not a character. Okay. For pretend like it's not a character.
Yeah.
How do you what if 3 dots, 2 dashes was a character? Right?
Yeah, I guess then this.
So you can't just greedily abort, right?
Right. Yeah.
Okay. So okay, but good approach. Anybody else? And feel free to like spitball the solution. You don't have to necessarily have like a pre-built solution or something. I mean, we are here to evolve the solution, and this is like an easy mode. So we are not talking about super complicated dynamic programming, backtracking. We'll probably end up using some sort of recursion or something, maybe.
Yeah, that's what I was thinking. Recursion with memoization.
Yeah, but forget the memoization at this point of time. Let's just see if the recursion actually gets us anywhere. How would you use recursion for this problem?
What if you so you take out, like you loop through the string, right? But on each iteration you take out that one index of the string and send the rest of the string like recursively, and you add all of those back to the character you pulled out. So that should give you like all the permutations, I guess all the combinations.
I mean, it sounds reasonable, but do you want to like think about it and see if there is a better way to find a way to articulate this in a more succinct way. Like, let's see if you can either translate this to an algorithm that's workable, or like even code if preferred, if you can.
So we would use recursion by removing the first character.
you can remove the first character and then you can do recursion. What does that give you?
So the base case would be when the string is null and there is no more to recurse. Like if we go by replacing just one character at a time, like remove one character at a time, and by the end of when the string is null, we reach the end of the string and we return true, saying this is a valid string, and we would repeat this same recursion pattern by replacing removing k number of characters at a time.
Nothing. Okay.
And whenever the string is not valid, we would return false, and that recursion would not count. I mean, contribute towards the count. And whenever the complete string is valid, we would count one. We would count one towards the final count. I don't know.
Okay, I think we have a interesting suggestion here. One is saying, can we convert the Morse codes to binary zeros and ones, and then do an AND operation between each of the binary codes of the alphabet and corresponding binary code? I don't know what that will give you. I'm not sure if that will get you anywhere. It's an interesting suggestion, but I don't know if that's going to get us anywhere. Like, I like how you're thinking about, since it's Morse code as binary, so totally makes sense, but I'm not sure how that will help us get any closer to this. I think NG, your suggestion of trying to use recursion seems to kind of make sense. I mean, here's what it is, right? I mean, fair enough. MALB, I mean, that might be probably the more formal way of looking at it. But let's go through, walk through this, right? So the way you'd look at it is that definitely if whatever input string that you have is actually in your set, right? Then you want to definitely one is a possible answer, right? There's one way of doing it. Okay, and if it's a empty set, empty string, then it's also one, right? So, or empty, right? Then it's one for sure. Okay, then if you have if the string is greater than, then what you do is that what you're doing is that you will just take one char, which is the first one. Okay, and then if that is valid, which it will be, all single characters are valid, then you want to add Morse code of decoder counter of like whatever. Whatever, right? So you want to just say, take that one character and then go. Then you want to take two characters. If that is valid, which is possibly not, like if you have two dots, then it's valid. If you have two dashes, then that's valid. If you have a dot and a dash, I think that is valid. I'm trying to look at where a dash and a dot is valid. A dot and a dash is valid as well. Like all of them are valid. Okay? Then you're fine. Then again, you want to do the same thing. Then you do, if it's three characters, and if that's valid, then you want to do this, and then all the way. Essentially, you want to go take n characters, but then we already know that none of the Morse codes are more than 5, right? It's always 4 at most. I don't see any single 5-character Morse codes. So you probably have to just do it up to 4. And you're good, right? Is that it?
So we would be missing out on the combination of these numbers also.
How?
So if we take the first dot
Let's
as a
just take
factor.
let's just take one simple thing as an example, right? Let's just
Mhm.
assume that we are taking 3 dots, which is S.
Okay.
Okay.
So yeah,
Then I think we can ignore this safely. The first comment is not required. It's automatically taken
yeah,
care of.
yeah.
Go on.
So
What do? You take the first character.
what I meant by we'll be missing on the combinations is yeah, dot plus morse of two dots and morse of one dot. Oh, one dot, yeah.
Right?
Okay.
Right?
Okay. So in line 52, morse of two dots will again be that double string. Yeah, basically two dots will be one dot. Yeah.
Mm-hmm.
Dot plus morse of dot. Okay. Yeah, I see. Yeah, then we won't be missing on anything.
Okay. So this will return 1. This will also return 1 eventually. Like one more, it will go further down, right? That's why it return 1. And then this will return dot.
Morse of, yeah.
This will return 1, and this will also return 1. So it's essentially 1, 2, 3, 4. 4 ways of doing it, and that's probably right because it is 3 E's, it is S, it is E T, and it is T E, right? Or not T. E I and I E are the 4 different ways. 2 dots is I. This one represents IE, and this represents EI, this represents EEE, and this represents S. Right? Does that make sense? Sounds a tad bit complicated. So why don't we actually translate this to code? Can someone attempt translating this to code? NG, if you're on the chat, then probably you might be at the best position to use Python if that's more convenient to you. So for folks who have joined late, we're trying to discuss, given a Morse code text where the spaces have been removed, how would you decode that? So for example, if I give you 3 dots and ask you to decode it, 3 dots can be either interpreted as 3 E's, it can be an S, it can be EI, or it can be IE. So essentially there are 4 different ways of doing it. So the question here is to figure out how would you, what is the number of ways in which you can decode a given Morse code input string. And we kind of have we walk through the basic algorithm at this point of time, and we've got somebody trying to edit that. I'm not sure if this not all combinations are valid, by the way. Right? If there are 4 dots and dash combinations, then you should be expecting to see 32 combinations, right? Not all 32 combinations are valid. Or even less, right? It's 63 combinations are there, even with with 31 combinations. And another thing is, in Java, I think you just do substring of 1, and that will give you the first character to the end of the character. Yeah, in Java, you just have to provide the number. It will just start from there. So just drop the comma. Yeah, that should be enough. Mm-hmm.
Instead of checking like the length each time, right? Wouldn't it be better to check if like if S is M like null, then return 0?
No, what's I didn't follow, Avi. Can you repeat the thing?
No, so at each time you're checking if the length is, I mean, if the basically enough of the string is available, and then you're doing a substring and sending it, right?
Correct.
So let's say I didn't check for it, right? So then you would basically send an empty string, or no? Wait, so if it's
No, you won't send an
yeah,
empty string.
so sorry.
You won't send an empty string, right? You will actually, there's no point of doing that. It will essentially be array index out of bounds.
So which would be null, right?
No, not
I mean,
won't be
okay.
null.
So in JavaScript, okay. So I think sure, okay. So in JavaScript, it would just be null, and then you could just handle that as a single case instead of checking for each
Yeah.
different lengths. Okay.
Do you need to do that for 2? Like, for example, if you look at the thing, right? So T is single, and
all two characters are covered, but yeah.
Single, and then if you look at double, A is double, I is double.
Yeah, all four combinations are covered.
Are covered. So which means then why bother checking for 2?
Yeah, we need not check actually.
Right? What about 3?
3, I'm not sure.
4, 4. So this is 3. This is a 3. This is a 3. 4, 4. This is a 3. 3, 3, 3. This is a 3. Did I miss a 3? 1, 2, 3, 4, 5, 6, 7 are there. I think, what am I missing? 3 dashes are covered. 3 dashes are covered.
Oh, line 38.
Yeah, there you go. That's why. So all 3s are also there. So you don't have to check for that too. That leaves us with only 4 dots. With only this one where it is.
Yeah.
So if I were to convert it as only check 4 is all that you need. Right? You have essentially you have this. So you have V, which is like 3 dots and 1 single dash. If I were to look at it as binary numbers, right? So this is 0, this is 1, this is 2. Okay. Dot, dash, dash is not there. Right? So not all combinations are there. So only 4 needs to be covered. That's it. So you don't need to do that for the other ones. As long as the length is
just remove the 3 also.
You can also remove the 3. So any concerns? Like any thoughts, any concerns as to now what's the problem with this? What is the challenge? What's the challenge with this? So this is great. Okay. This is perfect. Now what is any concerns that you see with this? What is the order of complexity of this particular operation? How many times do you think return morse of empty will be called?
4,000.
Whatever the answer is. If there are like 1 million possible combinations, then that return morse will be called 1 million times, right? The only way, because the return 1 is, if the answer is like 1,562,62, then you have to be adding, you're adding it only 1 by 1, right? You're not doing anything else more than that. So somebody else mentioned about memoizing. And that's what you need to do is you need to essentially, before you return this value, at this point you would actually say that right here, if memory.get of s is not null, right? If memory dot contains key s, return. That's it. Otherwise, right? You're doing that. Let me get rid of the 3 comments. That's not required. What this will do is that so it will essentially prevent duplicate computation at that point of time. Like for example, if you like had a whole bunch of these characters, okay, and you figured out that this many, right, is 1 million, say, then you will actually, what you will be doing is that you will be essentially doing this, right, with EI, or rather EE and this combination, or I and this combination you will be checking. Now you only compute this once, and the second time you just use the value 1 million as is. So this is like essentially you're caching the results of the computation, and you will be doing so many of these computations. Does that make sense? Okay. All right. So let's do a slightly different question, but it's kind of in the same vein. Okay. So this one is a simple question which I've seen asked multiple times as well. Is that people have used Excel, right? What is the first column? The name of the first column in Excel? A, correct? What is 26th column? Z. What is 27th column? It's AA. If you don't have Excel, then go check it out. Yep, it's AA. Okay. So now tell me what is 592nd column? And the reverse. Tell me what is AE B translate to? Is it? Is it 592 base 26? Think about it. It's subtly different. Why is it different? Why is it different? Any takers? Let's do that. Let's continue the math, right? What is the second? What is AB? 28, right? Divide the number by 26. So what I'm doing is a 592 divided by 26. So let's do 592 by 26. So I get 22 and 20. 22 times 26 plus 20. What's the next step? Any thoughts? So 1 to 26, but the remainder can be 0, right? Shrikant, good point. 1 to 26 maps to A to Z. So what's the problem? But then the when you do a division, the remainder is actually between 0 and 25, right? That's why it's not a base 25 conversation. Any thoughts? Folks are silent today. You guys should be able to unmute yourself and speak. Zero is not A, Harika, because first column is A, right? So by your definition, zero, first column will map to B, which is not what you want. So even if you offset by 1, that won't work.
Hi, this is Amrita. Maybe we should do like get the reminder and then divide by 26 and then loop through that.
Sure. So let's do this, right? So give me the logic that you have so far. 592. So 592, first step, I'm getting 22 and 22 times 26. So 22 is V. That's what I got, right? And this is T. So essentially the 592nd column should be VT, which seems to make sense. So it worked this time.
Mm-hmm.
Okay. So let's do the simple one. Let's do 26. I expect the output to be Z. Okay.
Okay.
If I do the division, first
the remainder is 0.
Essentially, it's 1 times 26 plus 0 is what I get.
Yes.
So this is what? Is this A what?
So 1 times 26.
You're the right track. Go on.
When we get the reminder, we should actually add 1 to that to map it correctly, maybe.
No, but in the last time you didn't, right? You just left 20 as is. VT is the right answer for 592.
So 22.
Like for AEB, it's essentially 1 times 26 power 2 plus 5 times 26 power 1 plus 2. That's the right answer for that one. Which is 808. Okay. So let's do the reverse and see if it works, right? So 808 is what? If you just divide, is essentially is 31 times 26 plus 2, or if I were to also continue with that other one, is essentially it is 1 times 676 plus 5 times 26 plus 2, right? I think I can just confirm the math. That's 808. Okay, this maps to A, this maps to E, this maps to B, and that works very well. So far your logic is so sound, except for 26. Any thoughts on how to handle 26? So what is 26, right? If you go by the same math, let's assume let's do the other one, like less than or equal to 26, then map. But what is less than or equal to 26, right? The remainder will always be between 0 and 25. No, that's not true. It is actually, it will also fail for ZZ, for example. ZZ essentially is 26 times 26 plus 26, which is 702.
So I think, Vivek, when we are adding this, since the remainder is always between 0 and 25, like we are trying to get a character, so we add the character A to it. So it will be like A plus 25, so that should be Z.
No, A plus 25 is not Z, right? Well, you don't want it to be. 25 should be mapped to Y, not Z. Like 1 should be mapped to A, not 0. Like the previous example, right? If you did that mapping that you just said, then then 808 will actually map to B, F, C, right? That's not what we want. It's A, B only.
Okay.
So the thing to think about is this, right? So how does ZZ map, right? So if you actually did the division, right, it essentially would be 1 times 26 times 26. That's how it should be, right? If you did the proper base 26 thing, plus 1 times 26 plus 0 is what it should be. Right? Normally, if you did base 26 calculation, correct?
Right.
But that's not what we want to do. Whenever you have a remainder of 0, what we want to do is that you want to borrow from the previous one, so this one becomes minus 1, and this one becomes 26. So if your remainder is 1 through 25, then you're good to go. If your remainder is 0, then what you do is that you borrow 1 from the left side and then make this 26. And that's about it. Like letter to column calculation is very simple. You can just use the exact same method that you have and you're fine. But the number to letter computation is essentially this is what you do, right? I think that the thing is very simple. Like if the value is 0, then what does it mean? Right? You can't have 0. Input 0 is not valid. Correct? And this is your column. Then what's the first thing you do? While first step is what? Correct? This is what we do, right? Normally, remainder and quotient. When I'm doing it in a long driven way, but that's it. That should take us, should this not work? Not the best way of doing it, but does this not make sense?
Vivek, just like instead of checking for the remainder, maybe like inside the while loop, we could probably just like decrement the val, like do a val minus minus. That way, it starts at 0.
No. That will actually cause other issues, right? You keep the val as is, and then if the remainder is 0, then you just borrow 1 from the quotient, and that's it. So let's run through this code, right? Let's actually run through this code for 702. Yeah, it'll continue, right? It'll keep repeating. Let's do that. So why don't we do something else? Why don't we do something like, EZPZ. Let's do this, okay? So this is essentially 5 times 26 power 4 plus 26 times 26 power 3 plus, what is P? Can someone tell me what is P? Okay, thank you. 16, right? Okay. So this is essentially 2,275,2698. Okay, that's the value that you're getting. So let's run through this code and see what you get. Okay, the very first step that you get is, if you notice, this number is actually divisible by 26 as is, right? So after the first step, first iteration, R is 0 and Q is this. Okay, so what we do is we set R as 26 and we set Q to this. Make sense? And this essentially gets us Z in the column. So far with me? In step 2, what do you get? We get this, and this divided divided by 26 is 407. Oh no, what am I missing? I'm missing something. No, I think I don't know. The number is wrong. This is power 1. This is power 2. This is power 3. I messed up the number. So this is essentially 35,594. Sorry, I was off by one power. So this is the value. Okay, this is divided by 26. It gives you 1369. Okay, that makes more sense. 1369. Okay, so now that this is 1369, so what's the next step? You make R as 26, and this one essentially becomes 1368. Okay, now 1368 divided by 26 is not divisible, but 1368 minus 16 is 1352. That divided by 26 gives you 52. So essentially this gives you a remainder of 16 and a quotient of 52. Okay, so this essentially got you a Z, and this gets you the PZ essentially. Now the remainder is 0 next time, and the quotient is what? Why 51? Did I miss the 5? Yes, I missed the 5. 105898. When I did the copy paste, I missed that. So 105898 divided by 26 is 4073. 4073. So this becomes 4072. 4072 minus 16 is 4506. That divided by 26 essentially gives you 156. That gives you PZ. 156 divided by 26 gives you 6 quotient, and this gets mapped to R equals 26 and Q equals 5. So this gives you Z, PZ, and then it gives you R equals 5, Q equals 0. This gives you EZ, PZ, and then since Q is out, you get out. Does that work? So essentially it's the same mechanics, except that the Z represents a borrow from the next setup. It's not base 26. It is base 26, but it's not the same. Does that make sense? So the code snippet that we wrote actually will work. Try it out. Try it out and then play with it and see how that goes. And then you should try out the letters easy peasy and this. The forward conversion is very straightforward. You just have to multiply it just like how you do numbers. So essentially map A to Z to 1 to 26, and then you just use the same position value system and just do the powers, and it just works exactly the same way. All right. Okay. So what I'm going to do is I'm going to stop the recording at this point, and then we can carry on with it if people have any more questions.